Hi there, this is Miss Barber here. I'm providing for you worked exercises of problems similar to some of the problems of your homework assignment. Suppose P and R are true and Q and S are false. Find the truth values of the following statements. Part A. P implies Q implies not R implies not S. The squiggly and the sideways L both mean not. Let's work these step by step. So P is assigned the truth value of true. And so we have true implies Q is assigned the truth value of false. Truth implies false is a false statement. That's from your implications table. And now, before we do the not R implies not S, R is assigned the truth value of true, so not true would then be false, implies. S is assigned the truth value of false, so not false would be true. And false implies true is assigned the truth value of true. And so we have, finally at the bottom, false implies true, and that implication is true. Let's continue. Part B. P or Q implies R and S. So let's assign truth values to each of the statements. P is assigned the truth value of true, so we have true or, and Q is assigned the truth value of false. So true or false, that's a true statement. Let's continue. R is assigned the truth value of true, and S is assigned the truth value of false. So true and false is false. And we have, finally, truth implies false, which is the only false implication. So part B is false. Determine the validity of the argument. P implies Q and R, not R, therefore not P. There are several different ways in which to determine the validity of arguments of this nature. Let's use the format used in your textbook, and we'll do so using truth tables. I'll start with 3 columns and assign truth values for each of P, Q, and R, and I need every possible combination. To ensure that, I will begin by giving truth value of true to the first 4 of P, and the last 4 I will give F for false. And then for Q, I'll do 2 by 2, so true, true, false, false, true, true, false, false. Now let's assign truth values for T, and we will alternate. So true, false, true, false, true, false, true, false. Notice we have 8 different possibilities. What I want to eventually get to is to determine a truth value for the first premise, which is P implies Q and R, and for the second premise, so I'll call that premise 2, which is not R, and the conclusion, which is given as not P. So now let's find the truth value first for Q and R, the consequent of P implies Q and R. So we'll look at the truth values. Q and R, true and true is true. True and false, false and true. When we have and, both statements have to be true. And so if we look at this quickly, we see that we get true twice. That's when Q and R are true. And again, Q and R are true, and the rest are false. Now, let's look at the implication. P implies. So we'll look at P implies Q and R. So T implies T, truth implies truth is true. Truth cannot imply false. So that's false. Third line, truth cannot imply false. Fourth line, truth cannot imply false. So that's a false. Now let's go to the fifth line. 1, 2, 3, 4, 5. False can imply true. So that's a true statement. Going on, false can imply false. That's true. False can imply false. That's true. And false can imply false. So that's also true. So we have the truth values for the implication P implies, Q, and R. Now let's get the negation of R for the premise 2. So we're just going to switch the truth values for the original R column, and we'll have false, true, false, true, false, true, false, true. And independently, let's look for the truth values of not P. So we're going to negate the truth values for the first column of P, which would give us false, 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 true, 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 true. And we now get to see two distinct areas in which the validity occurs. They occur at, let me count, 1, 2, 3, 4, 5. On the sixth one, we have true, true, and true. And on the eighth line, we have true, true, and true. And so we have demonstrated the validity. This is a valid argument. Give the negation, converse, and contrapositive of the statement all A's or B's are C's. It is much easier for me to negate a symbolic statement, and so what I really want to do is negate the statement that says all X, so all X, that is either A or B, is a C. And to negate an all, we need to make it existential. That means something exists that violates that requirement. So to negate that, I'm going to say there exists an X such that it does something. Let me think about that for a moment. What I want is that there exists an X that violates all A's or B's or C's. So we're going to look at an X that's an element of the set A, or an X that's an element of the set B, and we want to negate that that's an X that's an element of the set C. Now we actually did that, but it says give the negation, not the symbolic statement, so we need to write this out. We would write this as there is or there exists, so there exists an A or B which is not a C. Okay. The next part is to find the converse, and what the converse does is it switches the hypothesis and the conclusion. So a converse of P implies Q is Q implies P. Again, it's much more straightforward for me to do this symbolically, so I'm going to say all X, okay? And that is an X that's an element of C is either X an element of A or X that belongs to B. So symbolically that's correct, but we need to write this in an English sentence. So we would write that all C's are either A's or B's. Keep in mind that this is a converse of a statement is not necessarily equivalent. There might be instances in which it is, but it is not an equivalent to the statement. Give the contrapositive of the statement. The contrapositive, so the contrapositive of P implies Q is not Q implies not P. And the contrapositive of a statement is equivalent to the original statement. So let's mess with that for a minute, okay? So for every X that's not in C implies that the X is not in A or X is not in B. This is a cumbersome way to say stuff, so let's use De Morgan's laws. And using De Morgan's laws, we would say that for all X, okay, an X that's an element of C or an X that's not an element of C implies that X is not an element of A, and at exactly the same time, X is not an element of B. Again, we need to convert this to an English statement, so I would write this as all non-C's are non-A's and non-B's.